Okay, so on the way back from Bowling Green, we noticed that the steering arms were bent by the way that we had the truck strapped in. And since we're waiting on parts, this is a good time to go ahead and correct that. Before, what we were doing is we were strapping the tire on the inside like that, and then going down to the strapping points like right here. So both tires were being pulled in when you were tightening it down. And I think on the bumps on the way here, which is what's caused the steering arm to be bent. As you can see, that one is turned and this one's straight, so that's not gonna work. I did go ahead and purchase these new steering arms. They're upgraded steering arms. It's got a gusset on it instead of the thin ones that are there. So that's gonna prevent any of this to happen accidentally. But what we really need to do is get new strapping points. So I designed and made these two simple brackets that get welded right underneath here, similar to that, facing inwards. And then these get clipped there and will be tied down to the tying points on either side. So today I'm going to show you how I made these, designed them, and welded them. All right, so the first thing that I had to do is come up with something that this hook here can actually mount into. So I looked online and found a few examples, and then used the truck to figure out where I wanted to mount it to give me an idea like how far I needed to have a lip. So the first thing I did was I go on my CAD software, which is Fusion 360, and designed up what I thought was going to work well and the dimensions, and then I take that and I put it into a CAD software, which gives me the cutouts that I need, and put that on a USB stick, and we'll go out to the CNC machine. It's actually a rotary CNC router that I've rigged up to be a CNC cutter with some of their parts and some of my parts. I've also had to do my own electrical to make my older plasma cutter operate. As you can see, the cover stuff down there, all those are electronics I had to create to make that work. So put the USB stick in, load the G code. These are tie down 3s. And then I just confirm where I'm cutting to be sure that I don't cut somewhere where it's not supposed to. So now we play operation. Get the two parts out. Next step is I dry it or cool it off in some water. Enough so it's grabbable. And then I try to soften the edges a little bit before I bend it so that it doesn't scar the magnetic bender up. So you end up with that. Next thing we're going to do is bend this piece to the proper angle. Main thing is we just want this edge square because that's the design that we drew. We had this edge square, so we make that a 90. Something like that looks good to me. Bend it up to right about there. And because we're TIG welding, we need to clean up this edge that we're going to be welding against. Make sure it's nice, clean, shiny metal. It's nice and shiny. All right, got to get my welder set up. I use a Miller Dynasty 200 for TIG welding. Obviously straight argon. Currently set up with a foot pedal because we're at the bench, but I've also got provisions for a finger style trigger. And the good thing about the Miller Dynasty, I can change all the ramps and everything. I've actually gotten really good with the finger, and I prefer it now versus the foot pedal. So the next thing I do is you got to line this up. A lot of times you'll have a start and a stop. There's a start and a stop right there. And because any CNC machine, especially one that's not designed specifically for it, you're gonna have a little bit of a weirdness wherever it starts, and it's not gonna be completely square. So if you line those two start and stops up, then you're gonna have a pretty square or correct hole roundness. Then I'll just clamp that down. Another pretty important thing is to have a pretty sharp tungsten. This isn't as sharp as it really should be, but for what we're doing, it'll be fine. So I use a Miller welding mask, mainly for TIG welding and TIG welding only. It has a very clear lens that I can see well. With the bigger hoods, you end up hitting stuff in roll cages and stuff. So this is my dedicated TIG. The only thing I do with this is TIG welding to make sure that I don't get any MIG splatter or anything else on it. So all I got to do right now is just tack it down so that it can't move. I like to try to get at least 3 if I can, 2 if I can't, tacks. So now it's tacked down and it ain't going anywhere, and it can be fully welded. Generally, depending on what you're doing, you may want to try to weld backwards. Just keep rotating it backwards. That'll help prevent warp. But as thick as this metal is, and as we're only using 80 amps, that's not really much of an issue. So I'm just going to go right around as far as I can get and then move it as I need to. Around this outer edge, you got to be really careful with your heat so you don't pull the edge back. And I'm going to attempt not to do that. If you try to concentrate your heat on the thickest side and then just wet it over to the thin side that you're worried about. This is obviously not a welding channel. There's plenty of YouTube channels out there that teaches you how to weld. I'm just going to give you a couple of the tips that I've found that makes things a little easier for me. I always try to keep, especially if I'm doing it all the way around like this, I try to keep the torch always pointed at where I was welding to keep it shielded with the shielding gas. And I have, I think, a 7-second post shielding after the weld that I'll remain on it the entire 7 seconds.